Numerical models of severe storms are used to study the destructive forces seen in real thunderstorms. Beginning with observed temperature and wind conditions, mathematical equations are solved on a supercomputer to simulate the complex airflow and other features during the lifetime of a storm. Low-level air approaches the moving storm from the southeast and rises into the updraft. Mid-level, cooler, drier air from the west and south sinks in the downdraft. Weightless particles released near the ground at regular intervals reveal the complexity of airflow in the storm. Particles are colored orange when rising and purple when sinking. Streamers help show the paths taken by individual particles. Rotation of air in and around the storm is another one of its important features. Here, a twisting ribbon shows how air rotates around its path. The rate of twisting shows the amount of rotation. Large changes in the rotation are evident at different locations for each of the ribbons. Here, all the previous techniques are combined to show the complexity of the storm and the correlation of the different features. A cutaway of the cloud reveals its interior structure. With the use of numerical modeling and visualization, scientists are studying storms in greater detail. In the future, advances in these and other techniques will permit the understanding of smaller-scale storm features.